stone of mass 5 root 3 kilograms is held at rest by a horizontal force Fn and an inextensible string inclined at 30 degrees to the downward vertical. Calculate the horizontal force and the tension T in the string. We'll start by drawing a diagram. So we are told a stone of mass 5 root 3 kilograms. So immediately let's draw our weight. W is equal to mg. Now we are told that the mass is 5 root 3 and the acceleration due to gravity is 9.8. So our weight is going to be 84.8705 Newton. So we have our weight. Then we are told that it's held at rest by a horizontal force. So let's draw our horizontal force, F. And an inextensible string inclined at 30 degrees to the downward vertical. So there's an inextensible string inclined at 30 degrees to the downward vertical. So this will be the tension in the string. All right. So we know that Lami'S theorem is the operation of three forces, and we have three forces. We have W, we have F, we have T. And so let's find the angles between the three forces, because we know that the sign of the angles will give us the proportion of the sides, okay? So let's say we have the theorem is saying that A over sine alpha is equal to B over sine beta, and that is equal to C over sine gamma. So we just need the other two, the angles, the other two sides, yeah. So when we look at the angles between F and W, it is a 90-degree angle, it's a right angle. Yes, that's right. Now, this angle inclined, C, inclined at 30 degrees to the vertical, the downward vertical. If we draw a parallel vertical line here, we are going to have our alternate angles, and then we will also have a 30-degree angle here. So 30 plus 90 should give us 120, and that is the angle between T and F. Now what about the angle between T and W? Yes, if this downward vertical is 180 and we take away 30, we are going to have 180 minus 30, which is 150, and that should give us the angle between T and W. Now if we add all these angles, we should get 360. That is angles about a 10. 150 plus 90 plus 90 plus 30. That should give us 360. So let's apply our Lami'S theorem. Our W over sine, what is here? 120. That's the angle between the other two forces. Should be equal to F over sine 150. And that should also be equal to T over sine 90. That is how it works. So let's write down our Lami'S theorem. What is W? 84.8705 over sine 120. 120 is the angle between the other two sides when we take W. This should be equal to T over sine. What's the angle between the other two sides? We have 90. And that is also equal to F over, what is the angle between the other two sides? T and W sine 150. So we can have two different equations, one for T, one for Q. Let's find T. 84.8705 over sine 120 is equal to T over sine 90. So we can make T the subject, and we'll have 84.8705 sine 90 all over sine 120. And what will this give us? If we compute this, we should get exactly 98 Newton. And that is our T. about f, we'll take this particular w over sine 120 and we'll equate it to f. So we have a second equation. So w 84.8705 over sine 120, and this time it is equal to f over sine 150. So if we are making f the subject, we are going to have 84.8705 sine 150 all over sine 120. If we compute this, we should get F to be 49 newtons. So we can conclude, therefore, the tension in the string is 98 and the horizontal force is 49 newtons. Good. Let's move on to example 2. Example 2. A ball of mass 10 kilograms is suspended by means of 2 light inextensible strings. PB and QB, which are inclined at angles 30 degrees and 60 degrees respectively to the downward vertical. If T1 and T2 are the tensions in PB and QB respectively, calculate the values of T1 and T2 correct to 2 decimal places. Again, let's draw our diagram. We have a ball of mass. Once you have mass, you have the weight. So we have our W is equal to mg. Now, this case, we are not given our g. Let's assume it's 10. So we are going to have, oh, we're given it. Okay, the question said, take g to be 9.8 meters per second squared. Okay, so we are going to have our mass 10 times 9.8, and this will give us 98 newton. Good. Then we are told that it is suspended by means of 2 light inextensible strings inclined at 30 degrees and 60 degrees respectively to the downward vertical. Okay, so if we have our horizontal, we will have our vertical lines here, and then we have, so this point is going to be our B, and we can have P over here. So the PB is 30 degrees to the vertical, and then this will be Q. Q is 60 degrees to the downward vertical. So we have our tension T1 for PB and our tension T2 for QB. Now again, we can have a vertical line extending from the W. Our alternate angles here will be 30 degrees and 60 degrees. 30 degrees and 60 degrees. Now if we want to find the angle between T2 and W, we will have 180 minus 60, which is 120. And the angle between T1 and W, of course, will be 180 minus 30, which is 150. So we can apply our Lami'S theorem. 98, which is W, over the angle between the other two sides, 30 plus 60, that is 90. So 98 over sine 90 is equal to, let's take T1, we don't know T1, T1 over sine 120, that's the angle between T2 and W, the other two forces, sine 120, and this should be equal to T2 over the angle between T1 and W, that should be sine 150. Good. So let's take T1 sine T1. Yes, let's find T1. That's the first equation. 98 over sine 19 is equal to T1 over sine 120. So our T1 is going to be 98 sine 120 all over sine 90. If you compute this, the question set to 2 decimal places, you are going to get 84.8705 Newton, which is approximately 84.87 Newton, correct to 2 decimal places. That is our T1. Now for T2, we are going to take the 98 over sine 90 and equate it to T2, which is T2 over sine 150. So making T2 the subject, we have 98 sine 150 all over sine 90. Now if we compute this as well, we should get 49 Newton. So our T2 is 49.00, since the question said we should find it to 2 decimal places. So we have T1 84.87 and we have T2 49.00. Let's move to question 3. Question 3. One end, let me just clean this. One end of a string, one end of a string 10 meters long is fixed to a point A, and the other end is fastened to a body of mass 1.5 kilograms. The body is pulled aside by a horizontal force F until it is 0.5 meters from the vertical through A. Calculate the horizontal force and the tension in AB correct to 1 decimal place. Take G to be 10 meters per second squared. Alright, so for our solution, one end of a string 10 meters long is fixed to a point A. So let's say we have a point A. One end of the string is fixed to A. The other end is fastened to a body of mass 1.5 kilograms. So let's have automatically our weight, which is mg, and we have 1.5 times 10, giving us what? 15 Newton. We put it down there. Now the body is pulled aside by a horizontal force F until it is 0.5 meters from the vertical through A. So that means that it is pulled aside until it's 0.5 meters from the vertical. We are told that one end of a string 10 meters long. So this our string is also what? 10 meters long. Sorry, it's not 10 meters. It's supposed to be 1.0 meters. Pardon me. The string is 1.0 meters. Good. So this is our diagram. Now, we can see that there's a right angle triangle here. Now, let's call this tension T. And then we have a point B here. Yes, good. So when we take the right angle triangle here, we can find, let's say, this angle X. We have adjacent, we have hypotenuse. So we can say that cos X is equal to 0.5 over 1. So X will be the cosine inverse of 0.5. And that should give us 60 degrees. So if X is 60 degrees, and then these are angles on a straight line, angle ABF should be 180 minus 60, which is 120. Okay. Now we can tell that the angle between W and F is 90 degrees because F is a horizontal force. W is the weight. And then we would also have another 90 degrees over here. Good. So we can compute the angles between the forces. Angle between W and F is 90. Angle between T and F is 120. And then the angle between T and W is 60 plus 90, which is what? 150 degrees. So let's apply the Lami'S theorem. 15, which is the weight, over sine the other two forces, sine 120, the angle between the other two forces, is equal to, let's pick our F. F over, what's the angle between the other two forces? Sine 150. And that should be equal to T. Where is T? T is over here. Over sine 90. Okay? Again, we'll take any two. So 15 over sine 120 is equal to F over sine 150. So we can find F. We can find F. F will be equal to 15 sine 150 over sine 120. If you compute it, you would get 17.321 Newton. And we are told we should correct our answer to one decimal place. So this will be 17.3 Newton. That's our F. Sorry. That's not F. Just a minute. I apologize for that. 15 sine 150 over sine 120 will give us 8.6602 Newton. And that should be approximately 8.7 Newton. Yes. Now let's take the second part. We'll take 15 over sine 120 and equate it to T. 15 over sine 120 is equal to T over sine 90. So T is going to be 15 sine 90 all over sine 120. And this one should give us 17.321 Newton or 17.3 Newton. And that is so our force, our horizontal force is 8.7. Our tension is 17.3 Newton. All right. Thank you for your time.